1 inch per hour. So if you were to graph that yesterday, let me slide this over here. If you were to graph that yesterday, okay, here's snow in inches, and here's time in hours. If we were to graph what happened yesterday between 10 o'clock and noon, what's the matter? What's the matter? Oh, God.
There.
Whatever, it's all good. We're going to call 0, 10 o'clock. And we're going to call 2, we're going to call that 12 o'clock, just to make things simple, just for the mathematics. So 0, I went in, 2, I came out, 2 hours have passed. Here's 1. Also, this is inches. This is going to be horribly skewed, but we're going to call this 0 for 0 inches. We're going to call this 2 for 2 inches. So I went in and I collected my first data point. I came out and I collected my second data point. And connecting those 2 data points, since there's only 2 of them, I get a perfect fit line, don't I? I get a perfect fit line. The rise on that perfect fit line was 2 inches. The run on that perfect fit line is 2 hours, which means the average rate of change for snow in class that day, the average rate of change for that snowfall is 2 inches of snow, not show, snow, for 2 hours, which averages to 1 inch per hour. That's an average rate of change. Why is it called an average rate of change? Because what actually, Maddie hit it. What actually happened? It's actually an interpolation. But it's an oversimplification. Help?
Because this is Oregon and it will snow for half an hour and then not for an hour and then snow for half an hour.
And that's exactly what happened yesterday. What happened yesterday was from 10 to about 11:15, nothing happened. Or whatever was snowing wasn't laying. And then all of a sudden, it got ridiculously thick and ridiculously heavy, and it went like this, then it backed off, and then it hit again. That's kind of what actually happened yesterday. But do you see that if we just look here and here, we get the same result? Over 2 hours, it snowed 2 inches. It doesn't say what happened at 11:02 or at 10:47. Or how fast was it snowing at 10:30? It's saying over the 2 hour period from 10 to noon, how much snow fell per hour. On average, 1 inch per hour. Now, it's a little bit misleading because from 10 to 11, it was 0 inches per hour. And then from 11 to noon, it was 2 inches per hour. But that averages out to 1 inch per hour. And that's what an average rate of change is. You take whatever shape the data actually follows, and you create 2 points on it. You create 2 points on it that describe the average rate of change between those 2, in this case, time increments. Is that fair? That's all we're going to need to ask how fast I was going by the time I got to the end of my bike ride. Let's figure it out. Let's figure it out, shall we? Slide back over to here to our data. So what I would like to do right now is I want to figure out a few average rates of change for me along my bike ride. For example, what was my average speed for the entire ride? What was my average speed for the entire ride? So here's my entire ride. It started at 0 seconds. When did my ride end? What were we using for 200, friends?
11:08.
10:03, is that what it was? 10:34. So my ride started at 0 seconds. Slide this down.
We were pretty pleased with your speed increase.
You were or I was?
We were.
Oh, you were. Well, good. 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 11. So my ride stops at 10.34 seconds. So between 0 seconds and 10.34 seconds, what was my average speed? So what I'm going to do is I'm going to come over here. Let me see what I'm looking at here. I want to put this somewhere handy because I want you guys to use this. I want it to be helpful later when you actually crunch this. I'm going to put this right under there. So, over the entire ride, and that's from 0 to 10.34 seconds, what's my average rate of change? Or my speed, or my average speed. This can be called all kinds of different things, but average rate of change is kind of a nice formal title for it. Well, all we've got to do is apply this idea to it. How far did I go? How long did it take me to do it? How far did I go? How long did it take me to go? How far did I go? I went 200 feet, and it took me 10.34 seconds to do. I went 200 feet, and I did 10.34 seconds. So, my average rate of change was 200 feet in 10.34 seconds. My average speed, if you will. Now, what that is doing, now, by the way, that might be kind of hard for us to process exactly what the hell that means, 200 feet. There's 5,280 feet in a mile, so we can change it to miles, and then we got to change seconds to hours. I'm going to jump the gun a little bit here to save us some time. In your second project, it's called dimensional analysis. So your project for Thursday is actually on formulas. Your project for in week 6 is called dimensional analysis, and one of the tricks we teach you in there is how to do conversions in Google. So 200 feet per second in miles per hour. So I know. No.
Keep trying.
Oh, jeez Louise. Per 10.34 seconds. Good Lord. There we go. I averaged about 13 miles an hour for the entire trip. I averaged about 13 miles an hour for the entire trip. But that makes an assumption. Exactly. That makes the assumption, Harmony, that I started the trip at 13 miles an hour, and I traveled 13 miles an hour for exactly 10.3 seconds. That's how long it would take me to cover 200 feet. So in other words, I'm going to put this up again. Turn this off. That assumption that it makes is this. Pretend that's a straight line. That's the assumption that it makes. It's saying if you were going 13.1 miles an hour, that's my average speed over the entire trip, which means I'd have to start at 0 going 13.1 miles an hour. And I would pick up every so many feet, I would pick up the same amount, every so many seconds, I'd pick up the same amount of feet, and eventually I will have picked up 200 over 10.34 seconds. That's my average speed. Is that how fast I was going at the end of my trip? Kurt's saying no, and he's right. That's not. Was I going faster or slower? I was going faster. How about at the beginning of my trip, friends? Oops. So, let's take this out. Get the graph back. So the assumption is, here's 10.34 seconds, here's 0 seconds. That is obviously an incorrect estimate of what was actually happening on my trip, wasn't it? Because it's overestimating my speed at the beginning, and it's underestimating my speed at the end. Go ahead, Ben.
But isn't it the line like straight like that?
That's the cumulative line. You're talking about the cumulative, which would indicate the full 200. What you're thinking of is, you're thinking of a horizontal line with 0 slope. The line has a constant slope of 13.1 miles an hour, or 200 feet per 10 seconds, or roughly 20 feet per second. So the slope of this line is 20 feet over 1 second. It's consistent. What you're confusing is you're confusing a constant slope with a horizontal line. A constant slope just means that it's a straight line. And any slope that's positive or negative is going to be tilted along some kind of a diagonal. So that's just, it'll make sense the more we do this. So obviously, what just happened was we underestimated how fast I was going at the end. And we overestimated how fast I was going at the beginning. So in other words, this line, I don't really care how fast I'm going at the beginning because I know I'm going 0 at the beginning. I mean, it's clear. That bend, that would be your 0 line. How fast I was going at the beginning would be my horizontal line. So how should this line change to indicate how I'm doing at the end? What would it have to be? If I'm going faster, what do you think? If this is my speed, and you guys are voting that I'm going faster by the time I get here, how should this line be tilted? What do you think? Kind of like this, right? So in order to do it legally mathematically, maybe what I should do is not take such a huge view of this. Maybe what I should do is, let's mark the end of the trip at 10.34 seconds, but let's not start way back here. How about somewhere in here? Pick a time in here, friends. Pick a time in here. 5? Here, 5 seconds? Yeah. Sure, let's do 5. So 1, 2, 3, 4, 5. There's 5 seconds. So now, if I pick this point and this point, that will be an indication of my speed, which satisfies Tiffany's tilting up the line, right? That is now steeper, which means it will now be faster. The question, of course, I have is, how much faster is it? How much faster is it? So let's figure that out. And we're going to use some TIs to help us out with this. We're going to use TIs to help us out with this for sure. May I, friends, is it okay if I erase this up here now? Not this question, because I want to ask that question eventually. Okay, but just this right here. So now what I want to do is, I want to recalculate my average rate of change, but I'm going to change my frame of reference. So instead of the entire trip, let's do the average rate of change from 5 seconds to 10.34 seconds. So what I have to know, in order to answer that question is, I have to know first how much distance I traveled from 5 seconds to 10.34 seconds. And then I have to divide that by, work with me here, 5.34 seconds, correct? Because that's how much time, from 5 to 10.34, I traveled 5.34 seconds. So, what I have to figure out is, we know this is 5.34 seconds, I just have to figure out how much distance I covered in there. And here's where your TIs come in handy. You know the x values. You know the x value is 5, and the other x value is 10.34. What can you use? We learned it last time. Your table. Your table gives you these, yes, exactly. I'll show you another trick too that's actually kind of slick. You might not like it though, because it requires a lot of button pushing. You like this. Table you'll definitely like. There's your Y1 right there. I just hit second graph. Now you guys might not have the same numbers I do, so I'm going to, here. Do you guys look like that? Just blank? If they don't, just keep hitting delete, and the numbers will go away until they're blank. So now what I can do is I can type in 5, and I can type in 10.34, and at 5 seconds, I was at 57.377 feet, and at 10.34 seconds, I was at 202.4 feet. So how much distance did I cover between 5 and 10.34 seconds? What would I have to do with those numbers?
Just
subtract them. If you start at this distance and end at this distance, the distance between is the total amount of distance covered between them. So just take those values and subtract them. So we got 202.4 minus 57.377. Without that. Did I remember those correctly? Yeah. So I covered about 145 feet. I did 145 feet-ish, about 145 feet in 5.34 seconds. That's the distance, get the graph back. That's the distance from here to here, which would have been my rise, my change in distance, which is how much distance I picked up between 5 and 10.34 seconds. Let's convert that to miles an hour.
Why does that number not seem right?
What, does it seem too big?
Yeah, it seems way too big. Because
why does it seem too big? Think about it. We're basically, go ahead, Roy, go ahead. Was that you? I heard a voice coming.
Because that means
I didn't hear a voice coming.
We only go 5, that means we only go 50 feet in the next 5 seconds.
No. You need to go 50 feet in the first 5 seconds. That's what I did at the end of the trip.
okay.
That's the end of the trip. That's from 5 to end. You ever hear that question? It was a great question. Why does that seem so big? It seems so big. Who was in group 25? The 25-foot group? Who was in that group? Doesn't it seem like it took me forever to get by you guys? Because it took me 3 seconds to get by you. Think about that. It took me 3 seconds to get 25 feet.
That makes sense.
And I'm getting faster as I go past 50, which is essentially where 5 seconds is, which means it took me 5 seconds to get to 50, and then the other 5 seconds to get the other 150. Does that kind of make sense? So, in other words, I have to be going faster because gravity's pulling at me more as I go on. Good, I'm glad that caught you, Jay. Good, good, good. That's a great thing to notice, but realize this is the tail end.
Yeah.
We can also recalculate the average speed for the first 5 seconds, and it's ridiculously slow. So, now we've got 145 feet per 5.34 seconds. Okay, and friends, that means I was going, on average, about 18.5 miles an hour. So on average before, it was about 13 miles an hour. Now this is about 18.5, miles per hour.
What was feet, 145 on that?
145 feet per 5.34 seconds.
Right.
So I was going about 18.5 miles an hour on average between 5 seconds and 10.34 seconds. Okay, just cruising down the hill right there. Jake, make sense? Is it sitting well with you now? Is everybody else okay with that? Did anybody else notice the great dichotomy? The whole trip was 200 feet. I covered 3/4 of that past the half time point because of the increase in my speed going down the hill. I felt like I was going pretty quick by the time I got to the bottom. Matter of fact, how fast was I going at the bottom? Have we answered that question yet? No! We haven't answered that question yet. What we've answered is, let me mute the Google. Mute the Google. There's a song in that somewhere. We've answered on average how fast I went from 5 seconds to 10. But you see, I'm overestimating how fast I was going at 5, but I'm still underestimating how fast I was going at 10.34. So what should I do now? What do you think, to get a better estimate? Ben, go ahead, tell me. Maybe instead of going from 5 to 10.34, maybe scooch this bad boy even closer. How about 9? How about 9? Let's start at 9 seconds.
Okay.
Is that okay? So let's use 9 seconds. Tell me your name again, too.
Janaea.
Janaea, thank you. Go ahead.
Can you tell me why we can't just do, if speed is equal to distance over time, why can't I just use
200
Yeah.
divided by 10.34.
Yeah.
Somebody answered Janaea's awesome question. Her question is this. If speed is just distance over time rule, sweet Jesus rule, speed is distance over time, this is the greatest question. Why can't we just do 200 divided by 10.34 and convert that to miles per hour? Who wants to answer that question? It's a fantastic question. Tell me your name one more time.
It's Cheryl, but isn't it because it's so slow in the beginning?
So, in other words, what speed are we getting when we do 200 feet divided by 10.34 seconds? We're getting my average speed over the entire trip. I want to know how fast I was going when I passed that last group, which is, it's called an instantaneous rate of change. When you're driving in your car, when you're driving in your car and you're looking at your speedometer, is it giving you your average speed?
No.
No, it's giving you your speed at that moment. So when the policeman pulls you over and said he busted you going 75 and a 55, you can't say, but I averaged 55 and a 55 because I was going 20 for the first half an hour of my trip. That won't fly. Because at the moment he's pointing a hairdryer at you, you were going 75. That's the difference today. The difference is I want to know at the moment I went by that last group how fast I was going. Doing 200 divided by 10.34 just tells me how much I averaged over the entire trip. So in other words, how many of you have used the rule of thumb, 60 miles an hour is 1 mile per minute? You ever use that on a highway? To figure out how long it takes you to get somewhere, you're out on the interstate, 60 miles an hour is 1 mile per minute. You can average 60 miles an hour and still cover 1 mile per minute on average. But you don't have to be actually traveling 60 miles an hour for the majority of the trip. You could be going 20, 80, 10, 90. I used to have friends who said they used to give speeding tickets on the Jersey Turnpike. I'm from the East Coast. On the Jersey Turnpike by looking at the timestamps on the tickets. Suppose exit 1. By the way, you have to pay to use interstates in New Jersey. It's a kind of foreign concept to West Coasters, and I'm glad it is a foreign concept. So suppose 2 exits are 60 miles away. okay? And you get on and it stamps it at 11 o'clock. And you get off and it stamps it at 11:55. If the speed limit is 60 miles an hour, they can give you a ticket because you covered the 60 miles in less than an hour, which means that at some point you were going faster than 60. You see? So what I had friends that used to do is they'd get on, drive 80, then pull off at a rest stop and sit there for 25 minutes.
What's the point?
Well, they waste more gas that way. But nonetheless, Janae, great question. So Ben, I want to address Ben's comment too. So sliding up to 9 seconds to go from 9 to 10.34, won't that give us a pretty good indicator of how fast I'm going? It's going to be better. It's going to be better because now that line is going to be even steeper than the previous line. And we want it to be steep. To give you some fancy talk, these lines are called secant lines. Don't memorize this. These are called secant lines. In other words, taking a curve and representing it with 2 points, average rate of change, average whole trip, secant, average portion of trip, secant, average portion. What we want to do is get that point to lay on top of that point. Algebraically, your homework will have a question in this, a homework question that has you do this algebraically. But as we squeeze closer, this diagonal line is better representing how fast I'm going at that point of 10.34. Let's do it. Let's do it. I'm going to use the y's again.
Okay.
I want to use how many seconds did we travel from 9 seconds to 10.34? Right, 0.34, or excuse me, 1.34. So we know it's 1.34 seconds in the denominator, right? All we got to do is figure out how much distance I covered in that time.
44.33.
We're already on it. Thank you, Gabe. Fantastic, my friend. Did you use table again?
Yes.
Can I show you one more thing that you may or may not like? So definitely, you can use the table. So change the 5 to a 9. And now you went between 202.4 and 150. Did you notice that it's 202.4 and not 200? Did anybody catch that? It's not exactly 200. Why? When you did quadratic, what curve did it give you? The best fit, not the perfect fit. So it's off a little bit, because it gave you the best fit. Don't worry about that. Why are the lights off?
There must be some set on there.
I think so too,
I've
but
been in this room before and it hasn't ever done that.
it's me. It's me. It's the Italian. So here's one way to do it. Another way, if you want, in case you don't want to remember these numbers and carry on to the home screen, see if you like this, you might not. Remember that bars, Y bars thing to get Y1? Let me pull it up here so you can see it. You can do Y1 at 10.34 minus Y1 at 9. And there's the difference, 44.3. So in other words, it's a few more button pushes, but you can actually not have to remember the numbers from the table and then subtract them. It's up to you. I mean, it's on the YouTube video if you want to see how to do it, so you can get to it that way. So in other words, we covered 44.3 feet per 1.34 seconds. 44.3 feet per, what was it, 1.34 seconds, which means I'm now going about 22.5 miles an hour. So that's on average now. Remember, that's on average. So the question now is, how fast was I going the moment I crossed that last group? Now, the answer to that requires a bit more mathematics, and I have it designed in a multi-step homework problem to get down to the exact answer. But we can get damn close right here in class together with one more calculation.
Okay.
Why don't we just, let me turn the screen off first so you can see this. Say that again, say that again.
Can you go to like 10.33?
That's what I was going to do, Maddie. I was going to say, instead of doing all this, let's go straight to 10.33 seconds to 10.34 seconds. Which is a little ridiculous. We're now pushing the limits of the best fit curve a smidge, because we're assuming that it's precise to 1/100th of a second, which it may or may not be. So all we've got to do is repeat the math we just did over that. Fair enough? So what that means is we have to figure out how much distance I covered in 1/100th of a second. Because that's what the denominator is going to be, 0.01 seconds. 0.01 seconds. Everybody buying that? You buying that logic? It's the same thing, except now we're doing this. To correlate it with the curve that Maddie's looking at, we're now doing essentially this. There's my speed. So Tiffany, we have finally approximated the curve, the steepness you showed me before. When you said steepen the curve, you're going faster. Here's the average for the, Janaea, here's the average for the whole trip. There's a better representation of my final speed. Better representation, even better, of course, that would be 10.335 to 10.34, but this is a good enough point. 10.33 to 10.34. Shall we? Can I use the little shortcut that I just did earlier? Is that okay if I, now watch this. Here's another trick you may or may not remember. The damn lights are dimming, I can feel them. I just hit clear. I just hit clear. If you press second enter, you'll get the last thing you typed in again. And now you can just go back in there and type 10.34 minus 10.33. Did everybody see what I just did? And this is why I love having the video, because now you can go back and look at it. So basically, I press clear, but I want to recall those Y1s that I